Continue on in lesson 1.5. So this should be lesson 1.5, notes 3 that we're doing today. Okay. Lesson 1.5, notes 3, our third set of notes in this lesson. So today we're going to have the same process going. We're going to simplify and then solve, okay? So we're going to simplify first, just like we said yesterday. We can actually probably keep track of it better, do a better job with it if we actually do all the simplifying first and then start solving. And notice we are still working with equations that have variable terms on both sides. Our learning goal is I can solve equations that need simplifying and contain variable terms on both sides. Well, what kind of simplifying did we only come across yesterday? Remember, there's more than one type of simplifying step we have to look for. What was the type that we always encountered yesterday in our equations? If constants could be put together, we put them together. What's that called when you can put something together on the same side of the equation? Combining like terms. Yeah, combining like terms. So today we're going to have to do the other simplifying step also sometimes, and that is doing distributive property, getting rid of parentheses. So we're going to have to look for both to do. Now, when we do these, when you have both to do, you want to do distributive property first, and you want to do combining like terms second. However, I need your focus here. Okay, so let's put down problem number 1. We're going to just go right to practicing here again. So here's our equation as it starts. Okay, any simplifying need doing in this one? Yeah, but not until we do what first? What else is this one now?
Add like terms.
No.
Add the opposite.
Add the opposite. That's the first thing we're going to do. We're going to change it to add the opposite. So we have an m plus a -6. And the other one already has addition, so we're not going to mess with it. We're going to leave it as it is. Okay? So we're in our notebooks taking notes. Okay, now we're ready to go on and do our distributive property. We have to do the multiplying, and we have to do it on both sides. Not because when you do distributive property, you have to do it on both sides. It just so happens that both sides need it. So what's the left side of our equation going to read after we do the distributive property? Cody?
2m plus -12.
Okay. Who wants to give me what the right side is going to read? What's the right side going to read? Abby? 4m plus 16. Okay. Do we have any other simplifying to do? In other words, when you look on the left side, are there any like terms that can be put together? Cody says no. Do the rest of you agree with them? Yeah. Okay. And when you look on the right side, are there any like terms that have to be put together? No. So we're done simplifying, aren't we? We're ready to solve. Okay. Go ahead and solve this because you know how. When you're done, you may not have worked it exactly the same way I did. You might have decided to move the other m's, but we should still all get the same answer. Did you get m equaled negative 14?
Negative.
Negative 14? Okay, that's what we should get, right? So, how many of you solved it? Your first step was the same first step that I did. I subtracted 2m from both sides. How many of you solved it that same way? Okay. And you got negative 14 like I did? Yeah? Okay, how many of you said, what was your first step then instead? What was, those of you who did not do the same first step as those of us who raised their hand, what was your first step then? Cody?
I started with adding negative 12 with 16.
Adding negative 12 with 16. I don't think we would add negative 12.
Right. Adding 12 with 16.
Okay, adding 12 to both sides? Okay, so you moved the constant first. Yeah, and then you had to move, then what was your next move after doing that one?
And then I subtracted 4m from both sides.
Okay, so you just reversed the role of the constant and the variable term, and still got the same answer, right? Okay. Anybody else have another way that they did it? Some of us subtracted 2m from both sides first. Cody added 12 to both sides first. Okay, let's try this again. How many of you, your first move was subtracting 2m from both sides? Hands up. Okay, then the only one I have left to hear from is Aurora. Aurora, what'd you do first? You did the same thing as Cody. Okay, I guess I didn't ask that question. Anybody knew what Cody did? Okay, so you did the same thing. Okay, thank you. Okay, and you got negative 14 also, right? Both of you guys? Okay, good. Okay, let's go on and solve another one here. So the second one we're going to do, carefully write this down, okay? It's got all kinds of parts here. It's got 2's and y's and 4's in it, so make sure you get them all straight. Okay, what's going to be our first move? All of us. We all are going to make this first move. Abby? Yeah, change them to add the opposite, so what was being subtracted will become negative, won't it? What about this out front here? Is this a subtraction sign? No, it's a negative sign. We're going to just leave that alone. But we have a subtraction going on inside the parentheses that we're going to change. That 2, and another subtraction inside the parentheses will change, and no subtraction going on at the end here, so we'll just leave it as it is. Okay, what should be our first move in this one now after we've just got the subtraction change to add the opposite? Do we have any simplifying to do? Boy, do we ever. What do you guys, like waiting on here to answer that? Do we have any simplifying to do? Oh my goodness, yes, we got simplifying to do on both sides, don't we? Okay, so what should we do first? What do you think we should do first? Abby? Okay, so we're going to do our distributive property over here. Okay. And can we, just to try and get a little bit more efficient, get something else done in this step, can we do one other thing? Can we do the distributive property over here? Okay. Tune in for a moment. Do I have to take that 2 that we're going to take times that y and that negative 4? Do I need to take that 2 times this 2y out here?
No.
No, why not?
Because it's not.
It's not in the parentheses. It's like a tag along. It's like it's there. We can't forget about it, but it's not going to get multiplied by 2. So we're just going to do our multiplying here. So we have negative 4y plus, what's negative 4 times negative 4, class? 16. And then 2 times y is 2y. What's 2 times negative 4? Negative 8. And then we bring along our tag along that wasn't part of our multiplication, that plus 2y. Okay, are we ready to solve now? Or in other words, remember as I said, we have to ask ourselves probably more than once today, do I have more simplifying I can do? Yeah, what can we do yet, Devante?
Subtract the 2 from both the 2y and
Subtract the 2y from what?
the other 2y.
No, we don't really subtract them. They're on the same side, so what do we do, Josie? Add them together. And I think some of us need to start doing this, okay? When they're together, when we have y's on the same side, we're going to
Like terms.
combine them, circle them. We're going to combine them. We do not put minus 2y under both of them. That's what's messing some of us up. So, can we do anything on the left side? No, we're going to leave that as it is. And we're going to say that 2y plus another 2y on that side becomes 4y plus a negative 8. Okay. Are we done simplifying yet? Can we do anything on the left, anything else on the left side to simplify? No. Can we do anything else on the right side to simplify? No. So we're ready to solve finally, aren't we? Let's ready to solve. So go ahead and solve it because you of course are getting really good at that. Another thing I'm thinking that might be a good idea for us now, especially when we're getting these more complicated equations and having to solve them, once we get to the state that it's ready to solve, maybe a good idea would be to just draw a line going down from the equal sign, showing our 2 sides of the equation. And showing that we're really doing something on both sides, and if we're not doing something on both sides, then your work wouldn't be counted correct, even if you come up with the correct answer. What'd you get?
3.
Y equals 3, yeah. Okay. Show of hands, how many of you here did the same first step I did? Look up at the top. I did plus 4y to both sides. Okay, got the same answer as I did, right? So Cody, you did that way too? What'd you do first, Cody? I have a feeling you did something different. What was your first move when we started solving?
Like negative 4y plus 16 equals 2y plus negative 8.
Equals 4y plus negative 8? There should be that should be a 4y because when we multiplied here, or when we combined like terms, those became.
I know, but I thought you were starting from where you started to add like terms.
Nope, that's not. We're still simplifying up there.
Okay, so
This is my first step of work right here. When I do something to the same thing on both sides, the same exact thing.
I started out with adding negative 8 to both sides.
Ooh, we don't want to add negative 8. What do we want to add, class? If he
Add
wants to
8.
get rid of the negative 8, he needs to
Adding.
add 8. Okay, is there a difference between adding 8 and adding negative 8?
Yes.
Absolutely. So we add. So does your paper really say add negative 8, Cody?
No.
Oh.
Well,
Then you just-
adding the negative 8 to negative.
You're saying you're starting with trying to get rid of the negative 8. Is that what you mean? Okay, gotcha. Okay, you like to get rid of those constants first for some reason, huh? And it's okay. You don't have to do the variable terms first. Okay, one more, and then I'm gonna let you go to work on homework, okay? Oh, and make sure you're paying really close attention to all the stuff going on in this one. Oopsie, I have this wrong. Don't write this one here. This is, I didn't even write it right. Okay, so it's going to be 5 times 3x minus 3. Okay. Okay, what do you suppose we're going to do first? So change subtraction to add the opposite. Okay, count up. How many are there to do?
2.
3. Yeah, there's 3. This is a subtraction here. This right here is actually being subtracted from 3x. So this is a subtraction. So we have 3x plus a negative 3. Inside the parentheses, we have a subtraction. And let's make that a negative, let's put a 1 in front of it besides, so plus negative 1x. And then we have a subtraction inside the parentheses on the other side. So we have 3 subtractions to change to add the opposite before we go to work here. Okay. Boy, I'm pretty convinced there's simplifying to do. How about you? Okay. What kind of simplifying do we need to first start with on the left side? Yeah, we got to do our multiplying over here. We have to do our distributive property. What's that 3x that's out front? What's that 3x that's out front? Is it part of our multiplication problem? Yeah, what do we call those guys when they're? It's like a little brother or sister that's, you got to take to the movie with you and you really don't want to. They're tagging along, right? Tag along, yeah. So 3x is going to come along, down. It doesn't get left. We don't forget about it, in other words. Your parents are going to be very happy if you did ditch your little brother or sister. Negative 3 times 2 classes. Thanks, Jazzy. And negative 3 times negative 1x is? 3x. Okay. Okay. I want to hear from Devontae back there. I'm not sure he's awake and alive. Okay, Devontae, what are we going to do next?
Times 5 by 3x and by negative 3.
Okay, so we can do distributive property on the right side also. So what is 5 times 3x class? 15x. And what's 5 times negative 3? Negative 15. Okay. Ready to solve? No. What do we got? What's Jazzy?
Add the 2 and 3x's on the left side.
Yeah, we got some like terms. We got x's both on the same side. Circle them. We're going to put them together. What's 3x plus 3x then? 6x. The tag along in the middle has to come down. And then is there anything we can do on the right side further to simplify it? No. We have a variable term plus a constant, so those are going to have to remain like that. Okay? Is it ready to solve?
Yeah.
We are ready to solve. So we could show dividing our sides up so we realize that we're really now starting to solve where we do the same thing on both sides. So go ahead and solve that the way you want to solve it. And let's see if we all agree in the end again. anyone in here agree with my answer, x equals 1?
Oh, shoot.
Okay. So my first move was subtracting the 6x from both sides. Anybody make a different first move? Noah?
I grabbed the negative 6 and I added it to the negative 15 and I got
Okay, but you don't really add negative 6, what do you add instead? You're trying to get rid of,
6.
no, if we're trying to get rid of negative 6, we really need to do what to both sides? Add its opposite, so you should have added 6 to both sides.
That's what I did.
Oh, you actually did do that. We just keep telling me it differently, you guys. Okay, so you added 6 to both sides. That's your first move. Okay, anybody else make the same first move? Noah did? Well, Cody, you're gonna let us down. I thought you were moving constants first.
I did.
Oh, you moved the,
I added 15.
you added 15 to both sides. Okay. How about anybody decide to subtract 15x from both sides? Could we? Yeah, we could. Again, we probably didn't because we said then we just create negatives for ourselves sometimes when we don't need to. So, okay. Anybody have questions about, so what's different today that we didn't do yesterday? We're not saying we haven't ever done it before, but what's different today that we didn't have it yesterday?
Today, we made it from yesterday.
Yeah, yesterday we didn't have any parentheses to get rid of, we didn't have any distributive property to do. Today we have distributive property to do and sometimes some combining of like terms, or maybe just combining like terms and no distributive property to do. You just gotta look for what needs to get done. Okay, you can get started on your homework.